My name is Josh Wolf, the legendary Josh Wolf, as seen on the internet. Today, I was going to be streaming with Fatima Aruna from Lagos, Nigeria. But Fatima's got some issues with the power there at the moment. Seems to be a thing. Last week, we had David Odohi on the show, and he had the power go out, and the power is out there at the moment. The generator comes on at 9, apparently, so we're probably going to reschedule streaming with Fatima to probably tomorrow or the day after. Once we get that flat, I'll let you know. Let me just update the peeps on Twitter to let them know that that's not happening. Okay, so what I will probably do, let's have a look. Rescheduling. Bring this over here, and I'm going to share my screen. Add to the stream. Here we go. Rescheduling the stream with @SlimFatima. The power is out. Later in the week. Yeah. Technical issues. Due to technical issues, we'll let you know the date. The new date. Stay tuned. Okay, so I'm going to stream some work I'm doing on the DevRel Stats Collector, which is a project that I wrote to collect statistics about the kind of health of our developer community at Camunda. And it's a project that I wrote using Camunda Cloud. And not only Camunda Cloud, but I took the opportunity to go nuts and build it with this library called Nact. Julian Assange, pardon Assange. Okay, Nact, nact.io. Nact is Redux, but for the server, Node.js plus actors, and it's based on this idea in Erlang. So Erlang is a virtual machine called the Beam VM, and it was developed at Nokia, and it's been running for 20 years, as you can see. On the 19th of December was the 20th anniversary. Epic. Latest blog post, 20 years of Erlang. Open source Erlang. It's a dynamically typed kind of parallel distributed system, and it's used in telecoms, and it has like 9 nines or 6 nines of uptime, something crazy like that. And what it's most kind of well known for is like running forever. And I'm not sure exactly how Erlang achieves this, but you can hot patch code. If the actors crash, then they just restart. And so I've looked at Erlang before, and especially this language that you can use on top of Erlang called Elixir programming language. And Elixir was written by one of the designers, the founders of Rails, Ruby on Rails. And so he took the ideas of Ruby and applied them to the Beam VM. It runs on the Erlang VM. Low latency. Let's make this a bit bigger. Distributed fault tolerant systems. So it's a 20-year-old VM. Like you got the Java VM, you have the JavaScript VM, which has become like super good since Google Chrome came out, the Chrome engine. And you got the Erlang VM. The Erlang VM is super well tested. It's a great VM. And this idea of these actors, and the way actors work is it kind of reminds me of, you can program this Nact thing in Reason ML. Oh, should I rewrite it in Reason? That would be epic. But what it does is it has these actors that pass messages to each other. So it's kind of like the original idea of object-oriented programming, where everything's an object and it communicates by passing messages, like the original kind of Smalltalk idea, rather than this kind of tightly coupled code idea that we use now. So when we do object-oriented programming these days, our code all lives in the same kind of memory space. Whereas this original idea of objects passing messages and the way it's implemented in Erlang and also in, well, Nact, it all runs in the same memory space, but an actor can crash. Actually, I think with Nact, your whole program crashes, but you hook it up to a Postgres database, and basically the internal state of each of your little actors is now persisted into this state database. So if you restart your program, its whole kind of in-memory state is rehydrated out of the database. I mean, obviously it makes it a little bit slower because you got to have database access all the time, but it has like a caching kind of layer and flushes to the database. And it's kind of an architectural approach to building things. So I tried it with Nact in JavaScript, and I was inspired to do that because ZB itself, which is, you know, Camunda's cloud-based streaming workflow engine, is heavily inspired by Erlang, because one of the engineers who works on ZB is Dr. Deepti Akruna, and Deepti has like a master's degree in distributed systems engineering, and she's like really into Erlang, and that's kind of informed the design of ZB. So ZB uses actors. Let's have a look at the ZB GitHub. It's an easy way to get there for my history. Like if we have a look inside the source code here, let's have a look at the broker. If we go into the broker, source, main, Java IO ZB broker, clustering engine implementation, deployment distribution. Let's have a look in here. Deployment distributor. You can see here that there's this thing here called an active future. So ZB internally uses this idea of actors. And I think it was Mauricio Salaboy who said to me, it's using like its own custom, or maybe it was Nico. Someone told me anyway, it was like it uses its own implementation of actors. There are actor kind of libraries for Java, and I think one of them is called Akka. Build concurrent, distributed, reactive applications more easily. Resilient, reactive manifesto, high performance, elastic, decentralized, reactive streaming data. Simpler current, concurrent, and distributed systems. So actors and streams. The actor model. Message passing, avoids locking and blocking. Make it bigger. Instead of calling methods, actors send messages to each other. Sending a message does not transfer the thread of execution from the sender to the destination. An actor can send a message and continue without blocking. Therefore, it can accomplish more in the same amount of time. So it's kind of like the asynchronous model in the event loop in Node, which has like callbacks, you know, and except they can run in isolated memory spaces. And in Erlang, in the Erlang VM, the Beam VM, they run in their own super lightweight threads, which like take 1K per thread overhead. With objects, when a method returns, it releases control of its executing thread. In this respect, actors behave much like objects. They react to messages and return execution when they finish processing the current message. So in the Erlang VM, they're completely isolated. In this way, actors actually achieve the execution we imagined for objects. I wonder, let's have a look at the relationship between Smalltalk and Erlang. The wrong path. There we go. Smalltalk. Zoku Talk. Gamma and Erlang distribution. Dun, dun, dun. Look back at where object orientation came from with Smalltalk 80 with message passing, and look at the current state of inheritance and things like that. Have we gone down the wrong path? I never use inheritance. Inheritance is a form of tight coupling. This is the opening question. Actually, I just said that I never use inheritance, and inheritance is a type of tight coupling, but I actually used inheritance in the ZB Node client. But yeah, that I think is the... I might have, if I were to refactor that, would I do it differently? I think I would, yeah. This is the opening question of a QCon London 2010 interview with Joe Armstrong, the original developer of Erlang, and Ralph Johnson, long associated with Smalltalk, object-oriented programming, and patterns. Implementation of object ideas and not the ideas themselves. One of the things that always happens when you get an idea and it comes out and it's too radical for most people don't adopt the whole thing. They take a piece of it and then you get this approximation. Oh, even Smalltalk is not fundamental enough. Okay. 2 specific issues with Smalltalk. Fundamental error. It's hard for people who aren't Smalltalk programmers to appreciate this, but when you're programming in Smalltalk, when you're debugging in Smalltalk, you're debugging the whole system. Because in Smalltalk, you have everything in the image. You can't keep track of the versions between the old and new one. And there's also the issue of complexity. You build a system so it gets to the limit of what a few people can do, and Smalltalk doesn't work too well. Okay, application classes, development, debugging tools, and libraries in the image. I started wondering about what object-oriented programming was, and I thought Erlang wasn't object-oriented. It was a functional programming language. Then my thesis supervisor said, but you're wrong. Erlang is extremely object-oriented. He said object-oriented languages aren't object-oriented. I might think, though I'm not quite sure if I believe this or not, but Erlang might be the only object-oriented language, because the 3 tenets of object-oriented programming are that it's based on message passing, that you have isolation between objects, and have polymorphism. Okay, that's interesting. Well, I'd have to say in that case that a ZB system is a true object-oriented system. Let's have a look at the definition of polymorphism to make sure I'm getting this right. Does that mean it has an interface and you can have any implementation? Okay, close that. Provision of a single interface to entities of different types. A single symbol to represent multiple different types. Okay. Polymorphic. Behave differently depending on the type of argument to which they're applied. Function overloading. I don't think that's what it means. Parametric polymorphism. Generically values uniformly without depending on their type. Nope. Subtyping. Restrict the range of types that can be used in a particular case of polymorphism. In these languages, subtyping allows a function to be written to take an object of a certain type T, but also work correctly if passed an object that belongs to a type S that's a subtype of T. Static and dynamic polymorphism. Open an insecure page. Okay. Okay, let's have a look. Erlang might be the only object-oriented language. A single inheritance, dynamic typing, absolute requirements. Dynamic typing. Okay. Critiquing, blah, blah, blah. Closely set objects. Let's put some music on. Now, I can put music in my stream from... I think I use loopback to do that. Loopback audio on. And then if I go to here and go cam mic and choose audio, switch my mic over to loopback audio, H5. Okay. The H5 is coming in, and I can turn that one off. Let's add, if I open this, and then say YouTube Music desktop app. was on a Nickelback marathon the other day. Shingo Nakamura. Let's listen to him. Shingo Nakamura. Japanese progressive house shuffle. Yes. Now I can turn this down. How's that? YouTube's going into here, that's going to there, this one's going to there. Google Chrome. So I want to put this to here, put this to here, break these links. Like that. It's going to the H5. This one's, my microphone's going there. It's complicated routing. Can I rename this? Nope. Actually, I want this to go here. This one to go here. Let's get rid of these. Because then if the H5 goes there, yeah, this is my foldback channel. Monitor H5, because I can turn off my monitor. Now I can't hear anything. Turn it back on. These are the output channels. The H5 is going into this one, goes to there. So I think if I break that and break that. Okay, yeah, that sounds good. Now I can hear the music in my headphones, but I'm not getting a double echo of my voice. Turn that off. What? Let's turn that down. And I can turn it up a little bit in here. And let me check what the sound volume is like in Twitch itself. Play. Okay, so let me just pause the music at my end and I'll just listen to the stream. Right. Okay, whatever. YOLO it. Okay, back to this programming in distributed systems. Okay, message sending, small talk. Criticism directed towards small talk. Why is everybody object-oriented, structure and definition of a programming language. Okay, so anyway, let's have a look at the code. The wrong path. The one correct way to do everything, lols. Okay, so, I mean, the model itself is like a nothing, really. It's kind of, this is what kind of a model is this? It's got a start event, it's got a single task, and then an end event. And so what this run stats collection does is, you know, when this is activated, and it gets started via a timer. So this is started by basically a cron scheduler. And this was a limitation of ZB24, which they've fixed in 25, which is you couldn't have like a timer start event. So I can put a start event in here. and set it to a timer start event. Now you could do something like, the timer start event, timer definition type cycle was the only one you could do. And I could do PT1M, which means it'll start once a month. But I couldn't specify what day of the month it would run on. If I would have to actually deploy it on, 1 month before I wanted it to run. So if I deployed it today, which where I am, it's Tuesday, the 15th of December, it would run on, the 15th of January. And if I wanted it to run on the 14th of January, I would have to deploy it yesterday. But what you can now do is you can specify a date. Let's have a look at how we do that. Specify, or let's have a look at this. Let's see if we can find it in the ZB documentation. I think it's docs.zb.io. Okay, so how would I find this? Let's have a look. Reference, maybe? Variables, expressions. Expression language. So it uses the friendly enough expression language feel. Here we go. Temporal type, date. Date time plus duration operators. Cycle. Here we go. Define as a function that returns the definition of the cycle as a string in the ISO 8601 format of a recurring time interval. The function expects 2 arguments. The number of repetitions in the recurring interval is duration. Okay. Let me ask in the ZB Slack. ZB. General. How do I write a start timer? Let's make that a bit bigger. Expression to start a workflow instance on the 3rd day of every month. Can I do that? The other way I thought of doing it was now that we have this idea of now. So in feel, we now have this expression now, or today, for example, string today. The way I thought of doing it was to run it on a cycle. So run it on a cycle and run it once a day, like that. And then straight after it, to put a condition. Nope. Here we go. And then make this condition like, is it the 3rd day? Not the 3rd day of the month. Can I make this bigger? Yes, I can. Good. And then if it is the 3rd of the month, we'll do that. Like this. So I could do it like that. Every day. But there may be a way to just specify it to run on the 3rd day of every month. That'd be much better. So anyway, it runs once a month on the 3rd of the month, and then it will just run the stats collector. And then what happens there is that app.ts. See, here's my cron job scheduling here. So in my node code, this is just a constantly running application with this cron job scheduler. Where does it get the schedule from? Here we go. Gets it out of the environment. Oh, here you go. Oh, it runs on the 2nd of each month. Let's update that. So it runs on the 2nd of each month. I mean, I could have put this into the actual operating system cron scheduler, but then I have to configure the system that it's running on. And so in this nact library, nact, you can see here I've imported from nact. You have a number of different actors. So I've got an npm package download actor, a stats collector actor, a discourse forum stats actor, and a Google actor. So the Google actor writes the results into the spreadsheet, a Google spreadsheet. npm package download actor gets the number of npm package downloads, and the discourse forum stats actor gets the stats from a discourse forum. And so you have some stateless actors, 4 stateless actors. It's the cron job. And then what the cron job does is it runs a query. So it sends a query message to a stats collector actor. And because it's stateless, it will just create one. The stat sender. Yeah, okay, so here's the query that it sends in, stats query, which is an object you can see here, which has, it's like a declarative object, which has the parameters of the query that's going to be made, you know, which npm package downloads are we doing? So there's an array of those, and an array of discourse forum stats. Which forum we're checking? Here's my credentials. And this renamer part here is just for when we get the results of the query back, we're going to rename some of the parameters to, you know, what we want the keys to be. And then what dispatch does is dispatches query returns a promise of an outcome from the query, whereas dispatch just sends the message and then that's it, it's done. Let's have a look at one of the actors. npm actor. So it's a stats query actor function. Okay, so let's have a look at that code. Where do we create the actor? npm package downloads. Okay, I put a helper function around it. Yeah, it takes the actor function. Okay, at make actor npm package downloads. So this is actually not the entire actor. This is like the query function for the actor. So to create an actor, looks like an actor is basically a function that takes a message in a context. We run the query function and then send a message back. Result message, rename a function. Oh, you got to send a rename a function in the query. Rename a function. So stats query message, go to the definition. Yeah, okay. It's kind of like Redux in that it's just like convention driven. Whoops. Okay, so the npm actor here, message passing. I mean, this is such a simple thing. You know, it was originally written as a an AWS Lambda. And I thought this was a good thing to start with because this is not like a complicated architecture. It's just very simple. And so to do the entire thing, what we do is, okay, the Camunda Cloud integration. Well, let's have a look at the worker. So when the worker gets called, npm actor, discourse actor, Camunda Cloud. Here we go, bootstrap the integration, deploy the workflows, handler factory. Here we go. Okay, so here's the task handler. Execute worker, test worker. Okay, execute worker. So all this worker does is it continually polls for tasks of this type. So when the cron scheduler starts this workflow, a job will become available of this type here, which is stats collection. Stats collection here. And then what happens is when that job's available, this task handler gets called. So there's a handler factory, which it's dependency injection. It injects the spreadsheet ID, which spreadsheet we're going to write to. And it sends a query to the stats collector actor. So the stats collector actor is the one that kind of synchronizes the various queries. So if what is that? Type any. That gets injected. No type signature on there. That's cool. Stats collector actor. Here it is here. Takes a query, an actor context, and then what does it do? It finds out what the date is. So it finds out last month, gets the beginning of the last month to the end of last month, start and end date. And then it's going to go through the query. It's going to flat map over it. And okay, so what I've done is the actor name. That's a very Rails kind of thing to do. So my stats query, that's actually the name of the actor that's going to get called. And then it's going to get past this query to that actor. Dispatch. Nope. Stats collector. Context children get actor name, which means that the hierarchy of the objects when I create the stats collector spawn stateless. Somehow I must have made these actors the children of the stats collector actor. Let's have a look. So that's a name. That's a name. Yep. Enum. So I use the type system. I mean, that article before said it should be dynamically typed, but I've used static typing to configure by convention. Spawn stateless. Stats collector. This machinery here is like, I was thinking about this. This is what I was thinking of doing today, is refactoring it out of this actor system and into the diagram. Try doing that. But let's have a look at how this hierarchy is constructed. Oh, let me see if I can change the name of my stream. Edit. Here we go. NACT. Actor library for JavaScript. DB. Distributed workflow engine. Category. Science. Technology. Coding. Programming. Programming. Boom. Yeah, cool. Okay, so the stats collector gets created. Spawn stateless, spawn stateless. Okay, so here as it is here. So the hierarchy, this one is under the system, and then these ones here are children of the stats collector, which means when the stats collector runs, those children are available in the actor context as the children. And then because the query key is the name of the actor, I can look up the actor that the query is for from the key of the big query, and then I just send the query into it. Map the query out. This machinery here. Okay, so let's try refactoring it. Let's see if we can do a refactor and refactor it into this diagram. Same kind of architectural approach, but create a new BPMN diagram. So timer start event. Run on the 2nd of the month. Okay. So expanded subprocess. Okay. So I think what we can do is so basically the idea here is that the query should be decomposed into the various actors that need to act on the query. So in that case, actually what we should do is this. Here we'll do, what's this? Parallel gateway. These things will happen in parallel. And then what should happen in parallel is that we get a subprocess. Expanded subprocess. So we have discourse and we have NPM. That doesn't look very nice. Go here. What? Yuck. There we go. Like that. Yes. So I think we can give this a name. Yes. Okay, so NPM statistics. And this one here is discourse statistics. And I think we can make these as a sequential and a parallel. Let's make them sequential so that we don't have to worry about rate limiting. Performance is not really an issue here because this is like an asynchronous background kind of job. And then what we do is we just drop a parallel gateway in here to join them back again. I think that's the right symbol to use. Like this. There we go. We join them. And then here we say write to Google Sheet. And then we're done. Done for the month. Okay, so in here, we should collect npm package stat. And then in here, collect discourse forum stat. Like this. Now, essentially, this diagram here represents what we have in the code. So this machinery here, outcomes.reduce, is basically what happens between here and here. So these are sequential. Let's have a look at the actor for the NPM. Well, let's have a look. So if we're doing this flat map and then we're just sending the queries, so these queries are being sent in sequentially, but they're going to get executed in parallel because it's going to go over the network and get some data. Wonder how error handling takes place. This is going to be interesting. Let's have a look at this sequential multi instance. Is this a matter of preference if I wanted to put it out of code and into here? I don't know. I've worked with business analysts in the previous company before I worked at Camunda, and we were working on this is how I came in contact with ZV, a proof of concept for our new system. And we had a business analyst, Wendy, and she wasn't a programmer, but she could do BPMN. Like, she could grok that. She would never be able to design or implement a system if she had to write the exact syntax of this code, but this was easier for her to manage and work with. That's an exclusive gateway. Should make it parallel. It's a parallel join. It's going to join the payloads from these. I've never done a sequential multi-instance before. Input and output parameters, output parameters. Let's go to the documentation. BPMN workflows. Subprocess. Embedded subprocess. Variable mappings. New local variables in the scope of the subprocess. I could write a generic worker in that case, or could I? Let's have a look. This is the NPM actor. Okay, the discourse actor. Nope. But I may be able to just get rid of the specialization, or at least I can get rid of this machinery here, I think. Tasks. Can I search? Here we go. Multi-instance. Ta-da! Here we go. Multi-instance. Executed multiple times. Once for each element of a given collection. Like a for each loop in a programming language. On the execution level, a multi-instance activity has two parts. A multi-instance body and an inner activity. Container, yep. Activated, and one instance for every element of the input collection is created. When all the instances are completed, the body is completed and the activity is left. Okay, sequential or parallel. Do it sequentially. When one instance is completed, a new instance is created for the next element in the input collection. Okay, defining the collection to iterate over. Multi-instance activity must have an input collection expression that defines the collection to iterate over. So if we have a look at the code, at the moment we're iterating over npm actor. No, stats collector. The actor name. So types. Where's the query definition? Okay, stats query. Go to the definition of the stats query. Let's have a look at this. Whoa. Epic. Dude, I'm really into my parameterized generics programming. I love doing that stuff. Writing this machinery and then getting a concrete type signature out of it. I mean, look at that. Boom. But the actual definition of this thing, what's the config template? Oh. Okay. So this is what we would send into the, this into the workflow when we started it. So define the collection to iterate over. So the input collection is npm package downloads for this one. And for this one, it's discourse forum stats. Input collection, discourse forum stats. Input elements. Element stores a local variable instance. Okay. So this one would be npm package download, I'm going to call it. It's basically like a for each or a map. It's a map. npm package download is the, and then output collection. The output of if the input collection is empty, okay. And so do the same thing here. Discourse forum stat. Okay, output collection. The output of a multi-instance activity can be collected from the instances by defining the output collection and the output element expression. Output collection defines the name of the variable under which the collected output is stored. Results. Well, let's have a look at how we do it in here. So, the npm actor, for example, yeah, okay, it sends it out one thing called result, but the stats collector map and just returns it. Our tasks, and then it's going to reduce the tasks. So await promise all settled, and then reduce them. Response equals tasks. So output collection results, make both of them go onto the results tree. And then this one here will be discourse forum stats and under results. And this one here would be npm package downloads under results, like that. Output element defines the output. Results, result. That equals there. Let me uses messages to communicate. Async way. Oh, this looks interesting. I'm going to switch over to answering this question for a second. How should the model looks like that it get the complete state? Workflow, messages to communicate. Article created or updated, article deleted, trigger open FAS job. Open FAS is like functions as a service. It's like AWS. I'm going to chew some gum. Hope you don't mind. Send event to Mattermost webhook. Mattermost is like an open source Slack clone. I think it's open source. Online account created. Trigger the OpenFAS job. Yep. Convert email. Wait for the transformation. Send the confirmation email. Wait till it's sent. And it should say sent successfully. GraphQL update. Account activate. Could not activate account webhook to Mattermost. Send activation. Account activation email. Could not send verification mail. Receive error. Okay. Naming's a bit funky, but it's cool. So each message takes receive a failure or success event. The way you have done it now works, where you have two different messages. One signaling success, one signaling failure. If you want to send a single message and have a single message catch event with a succeed fail semantic, then you could use a specific key by convention. For example, operation, what would it be? It's not outcome, it's more like status, and set it to, no, operation success. True or false, and have a branch conditional gateway, but what that would look like is create a new BPM diagram. Okay, do something async. Which becomes your message intermediate catch event. Operation, okay. Handle failure, no, so we'll put the handle failure case down here. Handle failure. What would it be? Operation result. Like this. And then here you would say, okay equals false. And here this one's okay equals true. Handle success. And basically you're just kind of modeling the operation of a promise or a future. Start. This is the machinery of a JavaScript promise. Like this. desktop screenshot today at 9:10. Open. It is basically implementing the machinery of a completable future. Explicitly in your model using a convention for the messages, async result messages. Is this what you're looking for? Because I might have totally misunderstood his question. Back to this one. Now, this is an interesting problem because this big reducer that I've written here, this big reducer function, which is in the stats collector, is reducing things into errors and results. What happens if one of these things throws an error? So let's say we try to collect the npm package stat and the query is malformed and it 404s because there's no npm package. Then, I mean, we could end up with this triply nested thing which goes, so we're going to get a results array, output collection results, npm package downloads, success and failure. Yeah, that would work. I'd have to put the reducer in here. See, basically this idea of like message passing, synchronization of the process itself, in here it's all purely in the code, and you look at it and you have to reason about what this thing does. I've just basically redrawn, this is a diagram of this system. The implementation is not here, but the machinery and the mechanics of it is, you know, like if we have a look here, we have like query message, query, actor name, map, and then we get the queries out and then we send them, we get the actor and we send the query to the actor. So this query message, query, actor name, map is this. The only thing here is that I've had to concretize it at this level, whereas I used a convention for the task name. I think you actually can do it. You can actually do it that generic. Let me save this one. Save file as. Camunda, stats collector, stats crawler, BPMN. Let's call this stats collector v2. v2. And then file, save file as stats collector v3. So if I implemented this the way that it was implemented previously, I would do delete this and delete this. And then the way I would do it here is I would say statistics collection, genericize it. And then in here, I would say for every input collection, I'd have to say query. And then here it would be like the actor name. So what would we call that? It would be called the query namespace, query key would go into, let's call it key. Output collection goes into results. Yep. Output element. What happens if I leave that blank? Because it's so, let's have a look. Output collection. Yep. Output element. It's an expression that defines the output of the instance. Okay, so I actually did that wrong. Input, output collection. Accesses a variable of the instance that holds the output value. If the expression only accesses a variable or a nested property, then it's created as a local variable of the instance. This variable should be updated with the output value. A job worker providing a variable with the name result. I see. Okay. And then here we would say collect statistics. A single generic worker. No, I can specialize my workers by doing this. So if I make this into a service task type, and then we're iterating over the query key, input element key, query. Equals key. How do I do string concatenation and feel? Friendly enough expression language. Built-in functions, string concatenation. Split, mean. I wrote an article about this. zb.io/blog. Using field for expressions, part 1. There we go. Okay. So we'd do you could just do that. Like that. We don't need this anymore. We don't need the join anymore. So effectively what I've done with this diagram is I've lifted my generic by convention, machinery to here into the model. But if we compare that with this one, see this one, can I revert the file? Nope, there's no revert. What happens if I try to reopen it? Nope, don't save. There's no file revert. This thing never runs. Why is that even there? So this is pretty much meaningless. I mean, this initial implementation I did, everything is done in code. Like temporal.io, it's all done in code. In which case you get no benefits of using ZB or Camunda's kind of technology. Then we have this version here. I've concretized the worker types. So you can see what this thing does by looking at the diagram here. And my stats collector v3 I've lifted some of the machinery into the diagram, but I don't really get much for my money with this. I've just split the concern of my, you know, where things are managed. Some of the machinery is in the code, some of the machinery is in here. Out of the two, I would go with this one, because this one gives me more comprehensibility of my system by looking at the diagram. And then when we want to add more things in, we just add more parallel stuff. So of the three, meh. This one here, this one's kind of the worst of all worlds. I've now split where my code, how my code is orchestrated, but without much increase in intelligibility. Whereas with this one here, I now have a nice documentation of my system, what it's doing. I think this is the right one. This is going to become a blog post. Multi-instance. Okay, so the collector on the other side here, the output elements. This thing outputs a result, and then it puts it into this output collection called results. Can I do... No. I need to make sure that when I output my result, it is an object with a subkey. Yeah, that's cool. Same thing here. Like that. One thing is that I lose my type safety. Like this. Let's create a new branch and call it refactor to multi-instance. Okay. These are going to be specific concrete task types, not generic, switched on the input. So this here will be npm stat. And this will be a discourse stat worker. This type is write Google Sheet. Okay. So the query that goes in is going to look the same. When we start it, it's going to look like this. npm package downloads. It's a collection that's going to get iterated over. Discourse forum stats, collection that's going to get iterated over. Each of these workers is going to receive a single instance of that. So in lib, I have like a npm actor. And then what I'm going to do is I'm going to refactor this. I'm going to create an npm worker. So I've lifted this NACT actor message passing orchestration thing into the model itself. This is basically what NACT does. But instead of having to call, like in the stats collector here, when I send the query, I map over the input collection, and then I send a query to the actor. This is going to map over the input collection, and it's going to send a query to the worker. So in this npm worker here, I'm going to have an export function called start npm worker. It's going to take a ZB client and it's going to do zbc create worker. Task type is called npm stat, and it's going to take a job and a complete function. Now the job is going to have a particular type. I'm going to do this just to help myself out here. This. So import that. Where does that come from? So, type of, let's have a look. So I can create a specific type, worker input variables, and then I can go type of stats query. Now somehow I need to get the shape of this. Okay, so type worker variables extends stats query. Interface. A value type of stats query. Nope. What doesn't it like about that? Expression expected. Let's try this. Type T equals type of stats query. Okay, but we want the npm package downloads. Now, I think, let's just try this. Now, if I now in here say job variables dot, okay, but we need to pick that from there. TypeScript, pick. Partial into pick. Okay. There we go. Ta-da! Boom. Nope. Okay. Oh. It's an array. Okay. We have picked that one thing off there. Okay, so TypeScript, dereference, type of array. I think that's what we want to do. Destructuring. Bassarat, my man from Melbourne, works at Australia Post. Object destructuring. Array destructuring. How do I swap two variables? Yeah. Array destructuring, JS generation. Nope, that's not what I want. P and key of T. Basically, what I want to do here is I want to define my query in here, and then I want type safety throughout the entire thing. So once I get this, I'll make it into a helper function, because I want IntelliSense in my workers. Export type recursive partial. Extends array infer E. Array infer E. Array infer E. Key of T. I want to get the E out. I think the search I want is get type from array. TypeScript. How to get the type of array items. For 0. Like that. Nope. Type T equals worker variables 0. Nope. It's an array. So worker variables is an array. npm package downloads. So key. I think I can p and key of t. P and key of t. So I would do key of worker variables like this. It's a string. Type worker variables. So if we take the 0 off, npm package downloads. So if I go worker variables, type v equals worker variables, worker variables is that. And if I now go t, v should be that. Let's call that, rename that to p. It's funny. Ta-da! There it is. Oh man, I need a higher order type. Now, there's a new thing in TypeScript where you can do, I need a parameterized type. Let's put a string literal. Now let's have a look at TypeScript 4.1. It's a new feature in TypeScript 4. Labeled tuples. Nope. Okay, none of these. Okay, maybe it's TypeScript 4.1. Abusing the type system for fun and profit. Template literal types. Building other string literal types. No, it's not a string literal type that I want. So if I do this, type p equals, and then put in a q, and I say that's a q, should lose all of its type. Okay. Oh, you got to pass in a value. Oof. I got to put in a concrete value here. This is some BS because it means I'm going to have to every time I add a new, well, it does model actually this, because every time I add a new one here, I have to add a new concrete instance. At least I get that. So, you know what I can do here now, I'm just going to roll with it for now. I can destructure it like that. Well, unless I'm going to add the range to every single one, I'll have to generate the range in here. So in the stats collector, we generate the range here. So I'll just have to worker helpers. And in here, we'll do that. Dry out the code to start with. Day.js. Export this as a function. Get range. And then we would return start date. And end date. Like that. Get range. Dereference them off there. Got the package name, got the start date, got the end date. I need that. Where does result get? Oh yeah, downloads. So we should put the package name in here. Like that. But what happens if there's an error? See, the error handling is the... I guess we could do this. Catch E. And then what we would... We're not going to return it. We should do job.complete. the result. What I like about that. No, not job.complete, just complete. Expression is not callable. That's right. Complete with success. Complete failure. Error message. Dot message. And then the package name. Okay, so it has to be a string, so we'll make it a templated string. Like this. Dealing with success and failure in an array of tasks. It's one of the main problems in distributed computing. In programming in general, it's like how to get your code to work is 10%, and then 90% is what does your code do when it doesn't work? Explodes. And we should use the rename function. So in the stats collector is where I did the renamer function. So let's have a look. Go to the definition of the renamer function. Renamer factory. So stats collector, let's grab the renamer factory out of here. npm worker. Right. Okay, so there we go. We don't need to return a an object. We just need to return that. Where does that get used? There. Okay, so basically this. Okay, so even though I've defined this generic kind of thing here, I actually had to define a concrete interface there, which is even worse. Get rid of that. And here's my new worker. There we go. I've moved the actor system out of the code, the NACT actor system, into here. This is my new actor system. If only I could genericize this. I need higher kind of types. My wife keeps complaining about me chewing gum and making a lot of noise while I'm doing it, so it might be annoying. Let me get rid of it. I dropped this 100-kilo barbell on my mouth 3-4 weeks ago. Smashed 3 of my teeth. Cut the inside of my lip. It's got quite a big scar inside there. And ever since I've done that, I've started chewing with my mouth open. I kind of like couldn't use my mouth properly. Okay, so that looks good. So let's make a discourse worker. npm stat. Start npm worker. I guess I'll return the worker. Okay, so I'll make a discourse worker now. Discourse worker.ts. Grab the discourse actor. Discourse worker. Now here you can see my concrete implementation here. But what I can do instead now is I can do this to derive that. Discourse actor. Import that thing. No. Discourse worker. Import this. Get the configuration object. Ta-da! Change this to the Discourse forum stats. Okay, and go here, and then let's grab this part. And this should be called Start Discourse Worker. It's a discourse actor, really. Same kind of thing. Takes in the ZB client. Import. I love generics, as you might be able to tell, which is why I threaded this through. And this is discourse stat. And then here, I can say const, and then I can destructure the job.variables, and I should be able to get. It's not very good. What is that? Why doesn't that work? V. Forum URL. Yep. Type V. That's why. It's not a generic type there. Boom. Okay, good. My types. Love it. Okay, so const equals get range. Like that. And then I got start date and an end date. Okay. And then I just grab this logic here. See? Drop that in there. I'm not going to return it. I'm going to run it. Then, and catch E job.fail complete.fail. Complete with a failure E, and we're going to return forum URL. And e.message like that. Doesn't like about that. Right. That would be why. Cool. So I can now get rid of this. Okay, so it's going to get this thing, going to do all this. And then I'll just copy my rename a function thing here. Discourse worker. Res. My code is well written because it's easy to refactor. It's the only way you can tell if your code is well written. Here we go. Discourse worker. It's actually easy to refactor between NACT and ZB because ZB basically is the actor model, a ZB system. These are independent actors in their own isolated memory spaces, although I'm running both of my workers in the same memory space. Okay. Oh yeah, and the right to Google spreadsheet. I'll do 3 retries on these. 3 retries. Stats collector, run stats collector, stats.collector. So we'll call this one stats.collector.v2. Run stats collector. What? Okay. Too generic. Nice. Ridiculous. If any of these fail, the whole job will fail. That's the behavior I've chosen for this. Okay, write to Google spreadsheet. Write Google sheet. Google actor. So I make a Google worker. Hey, Google actor. Just copy the whole thing. Google worker. So instead of an actor, I just create a worker. So I go export function, start Google actor, start Google worker, takes in a ZB client, and return dbc.createWorker. Takes a function, that takes a job and a complete. Save that. Okay, so the type of the Google worker, the type of its input. Let's have a look at our diagram. It's going to get, okay, it's going to get an output element goes into those results. So my Google worker, I'm going to just explicitly write it and see if we can derive it. So the interface variables has an output collection called results. And results is an array of something, whatever this thing outputs. So, okay, I think I know a way to do this. Let's have a look. Google worker. So, this course worker. I'm going to lift these types into their own file to make them easier to work with. Okay, this. Import this. Now what it actually has I think I can do this. So P is, if I pick that, then I get T. What I want to do is I want to take so K equals T of T. V equals T, K. Zero. Okay, so ta-da. Nope. Nope. Okay, so I grabbed that out of there. Rename. How'd I do it here? Key of. Type S equals V. Rename. Okay, and if I do that, I get, yep, okay, good. It's a tight coupling between the data structure and the way that I'm extracting the types out of here. So doing this kind of magic here, I might be better off types. These are all the stats query types. I might be better off defining, instead of deriving it from the config JSON, actually creating it as an interface. Yeah, because when someone does come in and, oh, I want to extend this, they're going to modify this, but there's no guidance on what you should put in here, since I'm deriving the types from the concrete data structure. It'd be easier for me to do it. So I'm going to erase all these types because these are all actor types, and we're migrating away from the actor system. So here I'm going to export an interface, which is called stats collector config. And then it has npm package downloads, which is an array of npm package download. And then it has discourse. Let's get rid of a few of these things. Open the config.json again. Discourse forum stats, which is an array of discourse forum stat. Discourse forum configs. So there should be npm package config. Okay, so now export interface npm package config. And the npm cat package config comes from here. Okay. Types. Package name, which is a string. And then rename, which is downloads and a string. There you go. And then I just export the interface discourse forum config. And this one is string. They're all strings. That's a string. That's a string. That's a string. That's a string. There we go. Stats collector config. So in that case, we can concretize this. I don't need to do this anymore. Can get rid of these. And so this is actually an npm package config. No, it's a discourse package forum config. There we go. Type systems flowing through. npm worker. So this becomes an npm package config. Get rid of that, which means we get rid of both of these. Okay, so if I go to my types, I should probably rename this. Rename this symbol, make it a capital letter. Put an I in front of it. Yeah, why not? Rename this symbol. Rename this symbol. There we go. So my Google worker now it's an array of either an inpm package config. No. Let's go back to my types here. Okay, export interface type. And it's a discourse forum result. So if I look at my discourse actor, the discourse actor for each report signups and posts. Let's have a look at my stats collector. I'm just looking to see how does it key the different forums. Rename a function. Query. Yep. Results. Google actor. I'll worry about that in a second. Just get this discourse forum result. Pick from the iDiscourse forum the rename function. Gives me that. Okay. Key of rename. Lol. That. Ta-da! And it's a array of those. Okay. Type is npm package result. And it's this. Like that. Okay. Actually, what I can now do is if I go my npm worker, I got this, that, custom header shape, any, output variables, npm package result. Go to the definition. Function. T? Nope. T. T. Okay, so npm worker res. That's right. Complete function success. Updated variables. Updated variables. Yep. Which is an array of those things. Okay. Go to types. Like that. npm worker. Beautiful. Amazing. That type system flying through. Love it. Okay, the Google worker. Variables. This is npm package result. And it's an array of this or discourse forum result. Okay. Is that how it's going to come in? Let's have a look. These come out of here. They get written onto an output collection called results. Yep. And each one of these gets added to that. Each one of these gets added to that, and they get merged. Yep. So the input variables for this worker are variables. Const equals job.variables. What's going to be in here? What is this? Any. Why any? It shouldn't be any. Results. It's an array. Yeah, that's of type any. Worker input variables. Variables. Interface variables. Yep. Job.variables. Any. Create worker. Let's rename this to results. Why is that any? ZBC create worker, ZB client, create worker, results. Am I using the right function? Create worker, yep. Make it generic. Task type. Why? Task type is write Google Sheet. Ta-da! And then job variables dot results. This goes into results. Yep. Input element. So the npm package download gets added into results. Okay. What are the keys they get written on though? Let me have a look at the actual results. Sheets.google.com. I'm liking this. I'm having fun. I just had the intuition that ZB and the NACT actor system are the same thing. It's different implementations of it. Let's have a look. Camunda stats crawler. Okay, I think I can show you this. It's not a big deal. Oh, it didn't run on the 12th. Oh, no, it did because it ran for last month. Okay. ZB node downloads. Epic. So, where's this name come from? Camunda forum post, ZB node downloads. How does that key get inserted in there? Okay, so there, okay. Oh, I see. That's what the renamer function does. Renames them to that. Okay, so this negative. Okay, so it's pretty stats result. interface. So yeah, okay, what it actually looks like is this. Key is a string, and then this value here is a string. So if I go back to my Google worker, stats result. It's an array of stats results. There you go. Like that. Okay. So okay. Easiest thing to do is this. I do it like this. Results as outcome. Okay, cool. Boom. Make this async. Okay, so it's the easiest way. Put this in here. Comes in via closure. Message.outcome. Oh. Okay, so obviously I've enriched it with the start date. So let's have a look at the NPM actor. Results downloads. There's the result. Return the result. Okay, so the way this works is that because it's all running in memory, the stats collector generates the range, injects it into each of the workers. In that case, okay, so yeah, but if it's running on a timer, so we're going to fire this thing off once here. So the first thing we need to do is generate the range and add it into the payload. So put this here. Generate range. Date range. Type generate date range. Make it have 3 retries. Okay, so what this does is it's going to change the shape. So we're going to push that in, and then here we're going to say okay, export interface, iStats collector query, extends inheritance. iStats collector config, and it has a start date and it has an end date. And then let's have a look at how I generated it in here. No. Yes, that's collector actor. It's in here. Those are strings. Okay. String, string. Types. String, string. Okay, so generate date range. .ts. And then in the generate date range, export function, start date range worker. It takes a ZBC, which is a ZB client, and it returns ZBC create worker, which is generate date range as the type. Generate date range takes a job and a complete function. Now, generic types on this. Okay, import this. Import. The import type is an iStats collector config and no custom headers. No custom headers. And then it has an iStats collector query as the output type. So if I go to my NPM worker, and here I generated a date range. Oh, okay. That's easy. So if I go to generate date range, I can just do this. Complete.success, get range. Okay. Stats collector. Range. Okay. Get range. What? These types are not the right type. It needs to be a string. Let's see if I can change it to JSON. To JSON. Okay, so const start equals right. It's a string. In the Google worker .year. Any. Start date.year.month. I'm passing around the day.js object. So if I have a look in my npm actor, okay, is my discourse actor doing the same thing? Okay. Okay, so I guess I could do this. Const end equals end date. Let's see if this works. MMDD. start date is start, end date is end. Like that. We're not using the job itself. Start date and end date. So if I go back to my NPM worker, stats result. Let's go back to my types. Okay, so interface, date range. Okay, so extends that one and date range. That's it. So export interface, INPM package query, extends INPM package config and date range, and export interface iDiscourse form query, extends iDiscourse form config and date range. There we go. So my NPM worker actually takes an INPM package query now. Yeah, okay, so that means that it will now have a start date and an end date. Yeah. Ciao. Look at that. Okay, and my discourse worker takes an iDiscourse form query, no custom headers, and it returns a stats result. C E S QRS. Get rid of that. Yep. And then so now we can take this out. And the problem is going to come at the end where I actually need to access these things as subproperties, but I think I can just use the date.js library to do it. Okay, so it goes into the, where's my generate date? There it is, generate date range. Range, sends that out. Okay, my Google worker now. So I think I go start date equals outcome put this in here. Extends day range. if I go back to my model, I think they get written to a key called results. Yep. So results, like that. And that's an object. So if I go back to my Google worker, stats result, outcome dot update. And I think what I can now do is we'll get rid of the NACT library. And if we go to, I'm going to get the date library, day.js, Google worker. And, okay, it's in here. Right in the Google Sheets. Okay, so start date equals, and then I got to do day.js dot. Maybe I just do this. Test it. Okay, import no. So C TS node. Import day.js from day.js. Let's S equals Flickr. Boom. S. Okay, what happens if I go s.format? Like this. Yep. Okay, and then what happens if I call day.js on that? Does it convert it back to beautiful? Okay, great. That's what I wanted to see. See again. Okay, yep. And const end date equals day.js outcome dot end date. Here we go. Take that off. Take that off. There we go. Get rid of the actor code. Save that. Yeah, you got to complete the job. Complete.success. That's it. End date. Okay, we didn't need end date, so get rid of that. Now, okay. If it throws in here and it's uncaught, it'll automatically fail it, so that's good. That's all there is to it. Dude, sick. Okay, what's wrong with this? It's not liking something here. Oh, okay, it doesn't return a stats result. Discourse Wicker. Stats result. Lucky I found that. Yeah, cool. So for all my types, this is the ultimate stats result. Okay, so export. How would I distinguish between the result of an individual worker and the result of all of them? Individual result? Yeah. Individual results. So it's an interface, and it looks like this. Right? Because then all I need to do here is put individual result here. And that's an array of individual results, right? Yeah, they don't get merged. So let's just make sure that my Google worker is mapping over those stats results types. Yeah. Stats Google worker. No. For n determines a string. It's the key. But the thing is that, okay, the shape of this is going to be different. It doesn't get merged. It doesn't get merged. How did this thing get merged? Results. Yep. Okay, but results was a... Okay, for in JavaScript. I'm an array map guy. For in enumerable properties, object, yeah, okay. Non-symbol. Okay, so actually results is wow. Google worker. Outcome.results. Tab name. So I think it would be like outcome.results for each result, like this. Like that. Oh yeah, open this here. Await. So make this async. Like that. And then this would be in for tab name and result. Like that. Where does that come from? Oh yeah. Okay. That looked right. For each async. It's blocking, so one after the other. Should be cool. String. Individual result. Well, I managed to get rid of this, but the way that it worked before was it would not fail on an error. And the way to do that would be to catch the error in the worker, and then instead of failing, what's up here? Oh yeah, this is an individual result. Individual result. This course worker. Individual results. NPM worker. No custom headers. Yeah, I'd have to catch the result. The code, there's a lot of machinery in here. You know, like this kind of machinery, which is now lifted into something that's visible. I have a visible. One thing about this that is kind of like a bit of a downside to it is this output collections output element is not linked to my type system here. So I actually have to write those types. Can I get rid of the stats collector v2? Is that the name? Yep. Okay. Posted the results to ZB. Yeah, okay, now I need to instantiate my spreadsheet ID. Where's that come from? Handler factory. Oh yeah, okay, it comes out of the process. Env. Okay, so is it time to do this? I think it is. I'm going to kill all the NACT workers now. Let's get rid of all of them. Get rid of all the actors. Delete. Move to trash. Google actor, move to trash. NPM actor moves to trash. Stats collector move to trash. The worker helpers, we can now just move that straight into the generate date range. Like this. Easy. Get rid of that. Import from day.js. Ding. Save that. And just append these like this. Oh. Okay. Start date, format, and end date. There we go. Simple. Get rid of that. Get rid of this. Goodbye. Don't need that. No longer need this. Let's get rid of all the unneeded stuff. Good copiers, good developers copy, great developers paste, legendary developers delete. Rename a factory, types. Rename a factory, npm worker. Generate date range. Invar replacer. Discourse worker. And then Camunda Cloud. Okay. So here we should be able to say start date range worker, passing the ZBC. Start the discourse worker, passing the ZBC. Start the Google worker, passing the ZBC. And start npm worker, pass in the ZBC. So spreadsheet ID. Google worker needs the spreadsheet ID. Definitely exists. Just get rid of this. Stats collection test is the only thing here. Now it's all Camunda Cloud now, so actually this becomes basically app.ts. Yeah, get rid of these. libactor. Don't need this. Goodbye. Don't need any of this code anymore. Are we still going to run? Don't know. So Control C, put this into app.ts. Okay, there is an issue. And that is how this thing gets started and run. This is kind of where we started this whole thing. Like, how do I start it on a timer? See if anyone answered my question. BPMN error boundary interrupt. So screenshot. 10:55. Been going for 3 hours. This relies on not completing the job in the worker while the possibility of an error still exists. use a message interrupting boundary event, it may so if you wanted to do that, you would do it like this. All right. Start. Do something async. Get rid of that. Put the operation result there. Handle success. So, where? Oof. Handle success. And then we put a boundary interrupting event on here. Message boundary interrupting event. Handle failure, end, handle success, end, like that. It is an asynchronous, well, it's an operation success to the broker asynchronously. The end is on top, whatever. I think the receive event in your model can only be activated while the job is active, correlated. As soon as your worker completes the job, token moves out of that node, flow node. And if the worker And if the token is still in the flow node, then it only makes sense to do it that way. The worker has no knowledge of the failure. I'll just say that. So I wonder if I could do a boundary interrupting event on this so that we could signal a BPMN error. That's a business error rather than a technical failure. It would be a technical failure. Should raise an incident, yeah. Okay. But how we start this, let's go back and have a look. Anybody answer me? No. Boo. 19 replies. Boo, boo, boo. How do we start this? Okay, what happens if I deploy a workflow that starts on a cycle and then redeploy it, redeploy new version? Is the previous version stopped? Starts with a timer start event on a cycle. I also need the ability to run. So we should also have the ability to run it in a test mode. Start test. So what we can then do is this. Ooh. That's the other thing, is we have to hydrate it with the stats query. So maybe generate date range is actually get the query. Yeah. This thing here should actually be get the query. And so we change this properties panel to get query. Okay, save it. Oh, nope. Okay, so generate date range, get query worker. Rename the symbol, get query worker. Ding. Rename this to get query. So inject the query. Get query. Yeah. Go back to here. I can delete this. Legendary developers delete. So this get query. Import. Okay, so from one up here, we get the query, stats query. Let's have a look. Yeah, okay. Go to the definition. So what does it expect to get in? Nope, it should pass that back. It should pass this back, but it should get nothing in. So if I go to get query, nothing. Ta-da! And there we go. Nothing. Okay. See if I add something in like this. Nope. Very good. Okay. Boom. Love it. Leave it like that. What was the timeout used for? The actors. So we don't need the stats collector test anymore, because what we should do is put the process end test spreadsheet ID. Oh, that was the wrong one. Into the start. Yeah, okay. So types. Collect a query. And it should have spreadsheet ID. String. So we go back to get query. And this could have right. So here we go spreadsheet ID, and that's based on job variables test. And if it's a test, then we're going to use that. Otherwise, we're going to use, oh, what was that? Spreadsheet ID. And then actually we should elevate this for visibility up into here. Test sheet is that, and prod sheet is that. Go to the definition, spreadsheet IDs. No, not there. So if we have a look at types, spreadsheet ID, so app, we're not passing it into the Google worker, we're passing it into the get query worker. Get query worker. So get query worker. Spreadsheet IDs, and the type is of string. And that one is string. Sheet or spreadsheet IDs prod sheet. There we go. Nice. Well, I think that what we'll do is keep running it on the schedule. Get rid of the get rid of this timer. Ding. Delete. Like this. So here we would just say run on 2nd of the month. Like that. So start with test true. Test. So we no longer need the test collector. So we don't need an array there anymore. And what we do need to do is every time we run this function on the schedule, we do ZBC create workflow instance. Ding. And We don't even need the cron job. What's that? Run the compiler over it just to make sure that it makes sense. Boom. Yeah. That's what I'm talking about. Yeah, the system's much more comprehensible like this. The types are a little bit, once you start talking about partials, it's like you lose a lot of type safety. You know what? Instead of saying that it was a partial there, I should have said it was definitely and made the programmer put a partial on there. Problem is that it'll break everyone's type systems if I change it now. I might do it for a major upgrade. Major version. Nice. Now all I've done is I've moved the NACT message passing into this broker, and I also get, visualization here. I made a design choice about the generic level of generics, and I also get inspection at runtime. Anyway, I'll test it actually running later. That's it for now. Thanks for tuning in. Stay human. Protect the planet. Raise the consciousness.